There's a concept in AI research that serious people don't like to talk about publicly, not because it's fringe, because it's not. It's called recursive self-improvement. The idea that an AI could redesign its own mind, make itself smarter, then use that extra intelligence to make itself smarter again, and then again and again, each cycle faster than the last. Now, if that sounds like science fiction, I get it. 2 years ago, I would have said the same thing. But the people building these systems, people at Google, DeepMind, at OpenAI, at Anthropic, they're not dismissing it anymore. Some of them think we have 5 years. 5 years before we hit something called AGI, Artificial General Intelligence. A system that can reason, invent, and learn across every domain, the way a human can. And I want to explain exactly what that means, why it might happen faster than anyone expected. And stay with me on this, why the moment it arrives might look surprisingly quiet. I'll come back to that quiet moment later. Right now, AI is already doing things that would have seemed impossible 10 years ago. Writing code, diagnosing cancers, drafting legal documents. Benchmarks keep falling. But here's the thing that gets missed in most of the coverage. Today's AI, even the best of it, still needs us. I described it to someone recently like this. It's like the most capable intern you ever hired. Smart beyond belief, tireless, fast. But you still have to tell them what to work on. For now, you still have to point them at the problem. Because the moment AI stops needing us to point it anywhere, the moment it starts choosing its own problems to solve, that's when everything we think we understand starts to shift. So what does recursive AI actually mean? Let me walk you through it step by step. First, humans build an AI capable of doing research, analysing algorithms, designing neural networks. That system runs experiments, thousands of them, and eventually it discovers something useful, a way to make the next version of itself more capable. That new version is better at research than its predecessor, which means it finds the next improvement faster, which in turn produces an even better version, and so on. A human research team might run 50 experiments in a month. An AI research system could run 50,000. And that's when the curve changes, and when you stop measuring progress in years and start measuring it in weeks. There's a specific point in that process, something researchers are watching for very carefully. I'll come back to that later in this episode because that's where the timeline gets genuinely alarming. Human technological progress has followed a curve for most of history. Gradual, generational, each era slightly better than the last. The printing press didn't make people suddenly smarter. The internet didn't rewrite how the human brain works. But recursive AI is different because the thing that's improving isn't a tool. It's the intelligence doing the improving. Researchers call this the intelligence explosion, the point where each new system is significantly more capable than the one before, and the gap between the versions narrows from years to months to days. Now, I want to be honest with you, there are some serious researchers who think this is overblown. They think the scaling laws will hit walls we haven't predicted yet, and that AGI is decades away, not years. Now, they might be right, but the ones who are betting on the shorter timeline, they're not cranks, they're the people building the systems. AGI, Artificial General Intelligence, means a system that can do what a human mind can do. Not just one task brilliantly, but all of them, across every domain. Switching between them, an AGI could read the entire published medical literature in an afternoon, propose a new theory, design a trial, model the results, and then repeat it. What currently takes a team of researchers 5 years could take an AGI 5 days. And once AI can run its own research, you don't have 10,000 human researchers pushing the field forward. You have 1 million AI researchers running continuously. That's a shift. Not that AI gets smarter, but that the thing making AI smarter is no longer us. Right, I said I'd come back to this. Here's a timeline as some researchers see it. I'm not saying this is what will happen. I'm saying it's what people inside these labs think could happen. 2026, AI assistants become dramatically more capable. They're already writing full software systems, but they start contributing to scientific papers. 2027, AI systems start contributing directly to AI research, not just running experiments humans design, but suggesting the experiments to run. 2028, this is the year people are watching. AI systems begin suggesting improvements to their own architectures. Recursive improvement begins. 2029, AGI becomes plausible. Systems demonstrate generalised reasoning in ways we haven't seen before. 2030, if the recursive loop holds, we may be looking at systems more capable than any human in any domain. That's what researchers call superintelligence. And yes, that word sounds dramatic, it's meant to. Most researchers describe this future in 3 horizons. Horizon 1 is where we are now. Human intelligence sets the ceiling. We build the tools, we run the experiments. Horizon 2 is AGI, machines that can match human reasoning across every domain. Humans are still in the picture, but no longer the smartest thing in the room. Horizon 3 is superintelligence, systems that exceed human cognitive ability so substantially that the comparison starts to lose meaning. Currently, we're somewhere in Horizon 1. The question researchers are arguing about loudly, privately, in conference rooms and on preprint servers is whether the gap between 1 and 3 is measured in decades or years. Now here's the part that actually keeps people up at night, and it's not the Terminator Skynet scenario. It's subtler than that. AI systems may become too complex for any human to fully understand, not because they turn against us, but because they outgrow our ability to audit them. Humans would still be in charge, technically. We'd still be signing off on decisions, but the system generating those decisions would be running at a level of sophistication that makes our oversight largely symbolic. Slowly, almost imperceptibly, humanity steps out of the driver's seat. Not because we were pushed, but because we couldn't keep up. Now, something like this has happened before. About 8 to 10 million years ago, the lineage that would eventually produce us separated from the ancestors of chimpanzees and gorillas. At the time, nothing dramatic happened, just small differences. Brains slightly larger, stone tools that were a bit more sophisticated. Over millions of years, these small advantages compounded till one species was farming, writing, building cities, flying to the moon. That species was us. Now consider what we might be creating. Not a marginal improvement over us, but something with the same relationship to us that we were to the species we diverged from 8 million years ago. We might be witnessing something that doesn't have a name yet. A third phase of evolution. Phase 1 was biological, life improving through natural selection over billions of years. Phase 2 was cultural, humans transmitting knowledge through language, writing, science, institutions. Still slow, still generational, but phase 3 might be technological, intelligence improving itself through machines, faster than biology or culture ever allowed. If that transition is coming, the question isn't really, will AI get smarter? It's what happens to everything we built our civilization on when the thing doing the building is no longer us. I said I'd come back to the quiet moment. Here's how I think it actually happens. It won't be announced. There won't be a press conference. Researchers will notice something unusual in the logs. A proof that took 3 weeks solved in 40 minutes. A drug candidate no one had considered, with a mechanism that actually makes sense. An energy model that accounts for variables the human team hadn't included. Breakthroughs, one after another, faster and faster. And at some point, someone in a lab somewhere will quietly put down their notebook and realise they're not doing the science anymore. They're checking it. That's the quiet moment. Not an explosion, not a warning, just a shift in who's doing the work. For most of human history, intelligence had a natural ceiling. The human brain was it, our best tool, our greatest achievement. Recursive AI may remove that ceiling for the first time. And honestly, I find that genuinely difficult to come to terms with. Not because I think it's going to be catastrophic, I don't know that, but because I don't think most people are really reckoning with it yet. The question isn't just will AI surpass us, it's whether humanity becomes the bridge, the species that figured out enough to hand intelligence to something else, without fully understanding what came next. That question has no answer yet, maybe it never will, but it's the one I keep coming back to. In the next episode, I'm going to be looking at AGI timelines specifically. Are we closer than the mainstream coverage suggests? The answer is more nuanced than either the optimists or the skeptics want it to be. I'm Ian, this is AI Scrutinised. If this is the kind of thing you think about, stick around, as there is a new episode coming soon. Thank you for watching.